Modern periodic table of elements.
H.J. Moseley found that each element emits a characteristic pattern of X-rays when subjected to bombardment by high-energy electrons. By analyzing the X-ray patterns, Moseley was able to calculate the number of positive charges in the atoms of respective elements. The number of positive charges in the atom of an element is called the atomic number of the element. With this analysis, Moseley realized that the atomic number is more fundamental characteristic of an element than its atomic weight. The periodic table proposed by the atomic number based periodic rule is called the modern periodic table. Therefore, the modern periodic law may be stated as the physical and chemical properties of elements are the periodic function of the electronic configurations of their atoms. Now let us make modern periodic table of elements. So far the elements found are classified into 4 blocks. Those are S block, P block, D block and F block. The S block is divided into 2 groups because there are 2 electrons in the S orbital. The P block is divided into 6 groups because there are 6 electrons in the P orbital. The D block is divided into 10 groups because there are 10 electrons in the D orbital. The F block is divided into 14 groups because there are 14 electrons in the F orbital. The entire periodic table is divided into 18 vertical columns and 7 horizontal rows. These columns and rows are denoted by Hindu-Arabic numerals. Columns are called groups and rows are called periods. We call these 18 columns as groups of Roman numerals from 1 to 8 with letters A and B as follows. Let us get to know groups first. Elements from hydrogen to francium are called first A group elements. We call these the alkali metals family. The outermost electronic configuration of this group is Ns1. Elements from beryllium to radon are called second A group elements. We call these the alkali earth metals family. The outermost electronic configuration of this group is Ns2. Elements from boron to thallium are called third A group elements. These are called the boron family. The outermost electronic configuration of this group is Ns2np1. Elements from carbon to fluorovium are called fourth A group elements. These are called the carbon family. The outermost electronic configuration of this group is Ns2np2. Elements from nitrogen to bismuth are called fifth A group elements. These are called nitrogen family. The outermost electronic configuration of this group is Ns2np3. Elements from oxygen to livermorium are called sixth A group elements. These are called the oxygen family or the chalcogen family. The outermost electronic configuration of this group is Ns2np4. Elements from fluorine to actinium are called seventh A group elements. These are called the halogen family. The outermost electronic configuration of this group is Ns2np5. Elements from helium to radon are called 8th A group elements or 0 group elements. These are called noble elements. The outermost electronic configuration of this group is Ns2np6. Elements from scandium to actinium are called 3rd B group elements. Elements from titanium to rutherfordium are called 4th B group elements. Elements from vanadium to dubnium are called 5th B group elements. Elements from chromium to seaborgium are called 6th B group elements. Elements from manganese to borium are called 7th B group elements. Elements from ferrous to hassium of 8th column, cobalt to meitnerium of 9th column, nickel to darmstadtium of 10th column are called 8th B group elements. Elements from copper to roentgenium are called 1st B group elements. Elements from zinc to copernicium are called 2nd B group elements. Now let us learn about periods. There are two elements in first period. They are hydrogen and helium. These two are S block elements. There are 8 elements in the second period. They are from lithium to neon. In these, 2 are S block elements and 6 are P block elements. There are 8 elements in the third period. They are from sodium to argon. In these, 2 are S block elements and 6 are P block elements. There are 18 elements in the fourth period. They are from potassium to krypton. In these, 2 are S block elements, 6 are P block elements and 10 are D block elements. There are 18 elements in the fifth period. They are from rubidium to xenon. In these, 2 are S block elements, 6 are P block elements and 10 are D block elements. There are 32 elements in the sixth period. They are from cesium to radon. In these, 2 are S block elements, 6 are P block elements, 10 are D block elements and 14 are F block elements. In this period, cerium to lutetium of 14 elements followed by lanthanum are called lanthanides. These lanthanides are kept at the bottom of the table. The last one, 7th period, is filled in completely. They are from francium. In these, 2 are S block elements, P block is filled in completely, 10 are D block elements and 14 are F block elements. In this period, from thorium to lawrencium of 14 elements followed by actinium are called actinides. These actinides also kept at the bottom of the table. In this table, we call S block and P block elements are representative elements, D block elements are transitional elements and F block elements are inner transitional elements. This is the modern periodic table of elements. The Russian scientist Dmitry Ivanovich Mendeleev prepared the first periodic table in 1869. Due to completion of 150 years by 2019, the periodic table was prepared by Mendeleev. This 2019 year has been announced as International Year of Periodic Table by UNESCO.